The next lesson is 3.8. This is part A, solving basic equations with variables on both sides, and we're in your notes packet on page 15. Up at the top of page 15, you again see this little phone that kind of reminds you of the steps to actually solve your equations. And today we are finally going to use this whole move variable piece. And we're going to explain that now real quick. So your goal is basically to get all the variables to one side of the equal sign and get all the constants, the numbers, to the other side. So that's right here. This is your goal. And the way that we do that, if we have a variable, a letter on both sides of the equal sign, we are going to look for which one is smaller. And we want to move the smaller one. So positives and negatives are going to actually count here. If you have a negative on one side and a positive on the other, the negative number is going to be smaller, so we'll actually be moving that one. So in example number 1, we have 4x plus 10 on one side and 25 plus 5x on the other. We are looking to move the variables. So I'm noticing that I have 4x and I have positive 5x. This 4x is positive, the 5x is positive. Which one's smaller? So we're going to be moving the 4x because it is the smaller one. In order to get rid of, quote unquote, a 4x or eliminate it from that side, it's a positive. So we use inverse operations still. So we're going to do a minus 4x. And I'm going to ask you to be very careful today in your work. We want to make sure the x's get stacked right on top of each other and the coefficients are right on top of each other. In equations, what we do to one side, we absolutely have to do to the other side. So I'm going to go ahead, because this is my plus 5x. Right underneath the plus, I'm going to put the minus. And right underneath the 5, the 4. And right under the x, the x. So keeping my work aligned like this is going to make sure that I have all my like terms close to each other, which is ultimately going to make my life a little bit easier as I go through and do this. 4x minus 4x cancels out. You're left with a positive 10 over here. Equal sign, your 25 is going to come down, and you have a positive 4x and a positive 5x and a negative 4x. Together, that gives you a positive 1x, which we can just write as x. Now, there is nothing special or fancy about this one, so we're just going to add or subtract and multiply or divide if necessary. So to get this x by itself, I need to move my 25, which I'm doing with a minus 25. Cancels, positive 1x is what I wanted, and 10 minus 25 is a negative 15. Take a look at example number 2. We have the variables here. So we have a positive 3h and a negative 5h. Which one of those are we going to want to move? The positive 3h or the negative 5h? You're right, the negative 5h is the smaller one. So to undo it, we're going to do a positive 5h. And over on the other side of the equal sign, I'm going to stack positive 5h. Symbol, coefficient, variable. These will cancel, leaving me with a negative 1 over here. 7 comes down. A positive 3h plus 5 more h's is going to give me a positive 8h over here. I'm trying to do this as a two-step equation now. So this is one of those rule buster ones where the constant's out front. So I'm going to subtract that 7 because he's a positive right now. And we get 8h equals a negative 8. And I'm going to go ahead and divide through by 8. That leaves me with 1h, which is what I'm trying to get because I want the variable all by itself. H is equal to negative 1. In example number 3, I'm going to have you drop the line down here and look for your two different variables. So over here I have a 5x and over here I have a 2x. Which one should I move? So the 2x is smaller, so we're going to get rid of it with a minus 2x on both sides. And I'm going to have you go ahead, take it from here and solve this one. See what you get for x. So the 2x's cancel. This leaves you with 14 over here. 5x minus 2x is 3x, and you have a plus 2 that's going to come down. Subtracting your 2 from both sides, because now you're just at a two-step equation. 3x equals 12. Divide through by 3, and I get x equals 4 in this one. Go ahead, take a look at example number 4. I want you to identify which variable you're going to move and move it, and then go ahead, solve, get an answer for b equals. All right, so I'm moving this regular b, so I'm just going to minus b to both sides. This leaves me with a 2. 3b minus b is 2b, and we have a minus 4. Adding 4 to both sides, so we get 2b is equal to 6. Divide through by 2, and I get b equals 3. So now a word problem, just to show you what this is going to look like. We're going to flash forward a few years. You are looking to rent your first apartment. There are 2 final choices for you. Apartment A has a $1,000 security deposit, and it costs $1,200 each month. So, and $1,200 each month. This is just like your initial fee. So if we're kind of thinking which one is potentially going to happen more than once and going to get the variable, it's going to be this one, the $1,200 each month. So I'm thinking this is probably going to be our X. Apartment B has a $1,500 security deposit and costs $1,175 each month. How many months would you have to rent the apartments for them to cost the same? This is what you're going to see a lot of times. We're going to look for where are these two things equal. And we're looking at how many months. So we were correct in saying that the number of months is going to get the X. So if we're thinking about just apartment A, let's just talk expression. Apartment A is $1,000 plus $1,200 for every month that you stay there. Apartment B is $1,500 security deposit, but the rent's a little bit lower at $1,175 per month. And we want to know when the two of these are going to be equal to each other. So we're going to go ahead and set up 1,000 plus 1,200x is equal to 1,500 plus 1,175x. Solving this, even though the numbers are a lot bigger, we have 1,200x or 1,175x. Remember, we picked the one that's smaller, which is here. So we're going to subtract 1,175x. Those will cancel, leaving us with 1,500. And 1,200 minus 1,175 is going to leave us with 25x. That's positive, and we still have the 1,000 out front here. So rule buster, we subtract 1,000, and we get 25x is equal to 500. So we divide through by 25. We get x equals, you can do a quick little mental math here. 50 divided by 25 is 2, and add a 0 on. And x, remember, represents months, so at 20 months, these two apartments cost the same. What that means for you is that if you're going to stay at the apartment for less than 20 months, let's say you're only going to stay there for 15 months, one of the apartments is going to be cheaper, and you could plug in 15 for x and figure out what your cost would be at them. If you're going to stay at the apartment for, let's say, 2 years, 24 months, that means that the other one's going to end up being a cheaper option for you. But if you're going to stay in the apartment for only 20 months and you know that at this point in time, you would be able to pick either apartment and it really wouldn't matter because the cost would end up being the same. Example number 6 here. So we have Jonah and Joey are trying to save money and they're getting paid for completing chores. Jonah starts with $1 and completes 6 chores. Joey starts with $16 and only completes 3 chores. However, if they have the same amount of money after completing their chores, how much did they get paid for each? So Jonah is $1 to start and does 6 chores. We don't know how much he gets paid for the chores. Joey starts off with $16 and completes 3 chores. We want to move the smaller variable, which is going to be my 3x. So I'm left with 16. 6x minus 3x is 3x, and that's positive because I have the 1 out front. Take away my 1, and I get 3x is equal to 15. Divide by 3, x equals 5. And x represents the amount they get paid for a chore, so we can say $5 per chore. So again, you're looking to see when are their two expressions actually equal to each other. And that wraps it up for this lesson then.